What is up, folks? So this is another video having to do with trigonometric functions and such. This is literally based off of the review sheet for one of my students who has a test coming up. And I'm only going to do a few problems from the review sheet, but hopefully this is helpful. Again, a lot of this has to do with solving trigonometric equations, actually, I should say. And things like that. All right, so the first problem that we could tackle on the review sheet is actually 3a, and that would be 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. So in my opinion, this is a pretty good problem to rely on u substitution with. So the reason I know this is because it's a quadratic equation, it's a quadratic trinomial, and when you use u substitution, you should use the middle term variable. So u will equal cosine theta. And rewriting it such that u is present would be 2u squared plus 3u plus 1 equals 0. And at this point, we could attempt to factor this. That's a good first step. And a good way of knowing whether or not it's factorable is to multiply 2 times 1 and figure out what that number is. Okay, and obviously, I think that's probably pretty easy. 2 times 1 is clearly 2. I'm going to put a little halo around it because that's the magic number. And we need to ask ourselves, when it comes to this number right here, are there factors of this number, positive 2, that are such that when I add them, I would get 3? And the answer is yes. 1 and 2, when multiplied together, would give you 2, and 1 and 2, when added together, would give you 3. So we're going to rewrite this thing, and we're going to use the bomb method, which means we're going to blow up that middle term, and setting ourselves up to do factoring by grouping. What goes in here? Well, that would be those factors. And why is this legal? It's legal because you could always go backwards. It could always just be like 2 plus 1 is 3 and then go back up here. We're just literally exploding this 3 and turning it into that. The u is still hanging out over here. Then, interestingly enough, we're going to distribute that u in for the next line. So we end up with 2u squared plus 2u plus u plus 1 equals 0. Now we're ready to do factoring by grouping. We'll take 2 pairs, or 1 pair at a time, I should say. And you ask yourself, what's the GCF of these guys? Well, it's definitely 2u. So we're going to factor out a 2u, and that leaves u plus 1 over here. Now, if you're going to factor by grouping, it will always, always, always be the case that over here, you're definitely going to have a u plus 1 again. All right? It's always going to be that way. And then you ask yourself, what's the GCF of these guys that I could extract? What times u gives me u? What times 1 gives me 1? Well, obviously, that would be a plus 1. All right? That's the way to think about it. Once again, I would encourage my student, if she's not sure, not well practiced at factoring by grouping, to just find like a YouTube video about it and practice a couple problems. Anyway, it's always going to be the case on the next line that this, I'll call this the MVP parentheses. The MVP parentheses is going to be present. And there's going to be another parentheses. And the question is, what goes in here? Well, everything that's left over, everything that's not the MVP, namely 2u plus 1, that's what's going to go in there. All right, still equals 0. Now, what can we do with this information? Well, set up 2 different equations. 2u plus 1 equals 0. That's one equation, and the other equation is u plus 1 equals 0, corresponding with that and corresponding with that. Solving this one first, we end up with 2u equals negative 1, u equals negative 1/2. We're going to address that later, and this would be u equals negative 1. So, we used u substitution, so now we have to turn this back into cosine theta. So cosine theta equals negative 1/2, and cosine theta over here equals negative 1. And then it's a matter of, the way that I like to teach it is such that we're going to rely on this unit circle. So the cosine of what angle would be negative 1? In other words, which angle corresponds with an x coordinate of negative 1? Well, clearly, 1/2, I should say, pardon me, negative 1/2. Well, clearly we have 2 pi over 3 as an angle corresponding with an x-coordinate of negative 1/2, and we also have 4 pi over 3 corresponding with an x-coordinate of negative 1/2. So what angle would it be then? Well, the first one we could say is theta equals 2 pi over 3. It's going to be 2 pi over 3 because that corresponds with that x-coordinate of negative 1/2. But remember, the cosine functions have a period of 2 pi, so you go all the way around, infinite times. You go all the way around, so that means you have to throw on this extra 2 pi k, because 2 pi represents a full revolution, and k represents an integer, that could get multiplied to that full revolution around the unit circle. So in other words, if you could do it infinite revolutions around the unit circle, and you'll still land on an angle that has an x-coordinate of negative 1. All right, similarly, we're going to investigate this one where it's like cosine of theta equals negative 1. Well, there is only one angle that would give you that negative 1 x-coordinate, and that is pi, and that's kind of nice to know. It's always nice when there's just only a single angle that does it, at least base angle. So you know that theta equals pi, but for the exact same reasons, you could do these multiple revolutions around, so that's going to be 2 pi k as well. So that's how you do that problem. Okay, so the next problem to take a look at is 3b. All right, so 3b says 2 cosine squared x minus sine x minus 1 equals 0. Now, this is definitely a pain in the butt because we have two different trig functions, and that's a problem. If you have two different trig functions, it's always a good idea to turn them into the same trig, to work with only one single trig function. Now, the key is the Pythagorean identity, and that would be this identity. And the corollary of this identity right here is the following. So what this means is, if cosine squared x equals 1 minus sine squared x, then this cosine squared x also equals 1 minus sine squared x. So then we could, of course, put that in on the next line. So I'm actually going to write empty parentheses, actually. I always like to start with writing empty parentheses and then fill them in later. I like to kind of just do things systematically in that way. And then we have 1 minus sine squared x. Right there, let's go ahead and just, what is it? We could distribute this 2 into there, and we would therefore end up with 2 minus 2 sine squared x minus sine x minus 1 equals 0. And then we would want to simplify all this. So this positive 2 combines with the negative 1 to give us a positive 1. So we end up with negative 2 sine squared x minus sine x, what is that, plus 1 equals 0. Now, I'm about to sort of treat this like a quadratic equation, like a normal quadratic equation, perhaps do some u substitution, but this negative is problematic for us. Let's get rid of this negative. We don't want the first term to feature a negative number, all right? So what we're going to do is we're going to divide both sides by negative 1, both sides by negative 1, and that gives us 2 sine squared x plus sine x negative or minus 1 equals 0. All right, so dividing or multiplying both sides by negative 1 simply changes the signs over here. 0 just remains itself. And then I would do u substitution, as probably some of you are suspecting, where u in this case would be sine x. And then you could think of this instead as 2u squared plus u minus 1 equals 0. And then I ask myself, is this factorable? Well, one way of knowing is to multiply 2 times negative 1. That is a negative 2. And the question is, are there factors of negative 2 that are such that when I add them, I would get a positive 1. Well, actually, yes, it would be positive 2 and negative 1. So on the next line, I'm going to write that. So it's like 2u squared plus empty parentheses with a little u minus 1 equals 0. Well, what goes in those empty parentheses? That would be positive 2 minus 1. And then at that point, I'm going to want to distribute this here and here. So I end up with 2u squared plus 2u minus u minus 1 equals 0. And now I am perfectly set up to do factoring by grouping. So if I'm going to do factoring by grouping, what I'm going to want to do is pay attention to one pair of terms at a time. And focusing here and only here, what is the greatest common factor of these guys? Well, that would be 2u. I feel like this is very similar to the last problem. So that would be u plus 1 in there. And it's always, 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 always going to be matched over here. So I'm going to go ahead and just write u plus 1 over here. And then I ask myself, what times u gives me negative u? Well, that would be a negative 1. And that equals 0. So when we do factoring by grouping, you preserve what I refer to as the MVP parentheses, which is u plus 1. You preserve that, and you know you're going to have another parentheses. Now, what goes in here? Everything else that is not u plus 1, namely 2u minus 1. So that's going to be 2u minus 1. And then you can set it up with two separate equations. So we're going to block this off like that. Let's see if we can do the rest of the problem over here. So what do we have? We have 2u minus 1 equals 0. That's one equation. And we're going to have u plus 1 equals 0. That's another equation. So we're going to focus on this top scenario. If you were to solve for u, you would end up getting u equals 1/2. If you were to solve for u over here, you would end up getting u equals negative 1. Looking over here, u equals 1/2. Well, we know that it's not u. It is sine of x equals 1/2. And down here, it's going to be sine of x equals negative 1. And then you ask yourself, first of all, the sine function corresponds with the y-coordinate. All right, so what you're looking for is you're asking yourself, what angle is such that there is a y-coordinate of 1/2? So what angle over here is such that there is a y-coordinate of 1/2? Well, that would be pi over 6, and that would also be 5 pi over 6. So in a way, there are two answers to this problem right here. It's going to be pi over 6 and having to do with pi over 6 and 5 pi over 6. So let's actually tackle that now. So in order to tackle it, I'm going to make a nice red asterisk representing this scenario. And this scenario, where it's like sine of what angle equals 1/2, well, one of them is most definitely pi over 6. So we know that theta definitely is going to equal pi over 6. But since sine functions have a period of 2 pi, that's going to be pi over 6 plus 2 pi k. And then we have to take into account this 5 pi over 6. We also know that theta is going to equal 5 pi over 6 plus 2 pi k. All right, so that is one of the answers to our problem. Okay, asterisk, asterisk. Over here, we'll treat this guy separately. We can kind of stick with this area over here. The question is, what angle is such that there is a y-coordinate of negative 1? Well, the only one that works is pi. So this one's fairly straightforward, where it's like x. I probably should have wrote, actually, let me backtrack. Probably should have wrote x here, because we're denoting the angle as x. So it's good to be like precise with that stuff. So anyway, we know that x in this case is going to equal pi plus 2 pi k. And the 2 pi k is for the same reasons that we used it over here. So that's how you do that one. Okay, so the next one is going to be 3c on the review sheet, and that is 5 minus 4 sine x plus p equals 3. So this is interesting because we have p here, out of nowhere. And it's also interesting because this angle is sort of split apart into this like addition situation. However, it's important to not get intimidated by that stuff. Bottom line is we're not trying to solve for p. So we could send p off to the right, at the end of this. We're still just trying to solve for x, right? So a good idea, regardless of what the heck we're going to do with p, a good idea would be to get at least this term by itself. All right, let's at least begin there, and then we could get sine by itself, right? And then we could take it from there. All right, and let me erase that though. It's a little distracting. So obviously, if we're going to get the second term, 4 sine x plus p by itself, we're going to have to subtract this 5 right here, right? We're going to have to subtract that 5. And that would leave us with negative 4 sine x plus p equals negative 2. And then at that point, we could divide both sides by that negative 4 right here. And when we do that, what we're going to end up with is sine x plus p equals 1/2 after reducing. Negative 2 over negative 4. That'll become 1/2. Now we have this interesting situation where we have this addition scenario in there. But at the end of the day, in the big picture, it's still sine of some angle equals 1/2, right? And therefore, we could kind of find out what that angle is right now. We might not find out what x is just yet, but we could find out what this angle is. The sine of some angle equals 1/2. Well, that would be pi over 6, and that would be 5 pi over 6. So we've already kind of covered that. So let's set up the following scenario. We know that x plus p is going to be pi over 6 plus, 2 pi k because of the period. We also know that x plus p is going to equal 5 pi over 6 plus 2 pi k because of the period. Looking here, we're not trying to solve for x plus p though. We're trying to solve for x. So that's very easy. We're almost there. All you have to do is subtract p from both sides and you end up with x equals pi over 6. And I'll say minus p right here plus 2 pi k. I think it's good to end it with the 2 pi k thing. And then over here, it's going to be x equals 5 pi over 6 minus p plus 2 pi k. Keeping in mind, we're not concerning ourselves with what p is. It's just a number. Who knows? But we know that x is equal to this. We know that x is equal to that. All right, this next one would be 3d. That's a d. And that would be cosine squared t sine t minus sine t equals 0. This one, I can already see we might not need to force it to feature only one trigonometric function because I'm already seeing an opportunity to factor out that sine t. So we could have sine t on the outside, and we'd end up with cosine squared t minus 1 equals 0. And, now I was going to say this is a Pythagorean identity, but I don't think it is. It's not. If it was 1 minus cosine squared t, it'd be a different story. But bottom line is, you know that you have some number times another number equals 0. Therefore, if this number was 0, then the whole thing would be 0. And if this whole thing was 0, then it would be 0 times whatever the heck that is. And this whole thing would be 0. So once again, we're going to have two separate equations that we could set aside, namely that and namely this. Now, looking at the first equation, it's very straightforward. The sine of what angle gives you a 0? In other words, since sine corresponds with y-coordinates, which angle would give us a y-coordinate of 0? Well, there are two of them. We have angle of 0. That would give us a y-coordinate of 0. And we have an angle pi. That would give us a y-coordinate of 0. Now, at the end of the day, we could just write the angle 0, and we could be like, okay, 0 plus pi k, because it's like if we do a half revolution every time, we'll hit an angle that corresponds with a y coordinate of 0. So I'm comfortable just saying t equals 0 plus pi k. And we can also really call that pi k. Kind of a unique answer, but there you go. All right, looking over here, we have, let's see, a little divider. Cosine squared t, after adding 1 to both sides, that would be 1. And then we can take the square root of both sides. Now, when we take the square root of both sides, we will definitely get cosine t over here, but the square root of 1 is positive negative 1. All right, and I might as well just kind of do this, right? It's always a good habit to do the plus minus thing over here, and you have plus minus right there. So the question is, the cosine of what angle corresponds with an x coordinate of positive and negative 1? Well, that actually would be the same thing. That would be the same thing. It would be this one and this one. So, you know what? Same answer. So this is the answer. So that's how you do that one. All right, looking at 3e now. That is 2 sine squared theta plus 5 cosine theta plus 1 equals 0. All right, so let's take a look. Well, sine squared is definitely 1 minus cosine squared, and that would enable us to have like a straight up quadratic trinomial. So due to the Pythagorean identity, I'm going to switch this sine square with a 1 minus cosine square. By now I know that my student most definitely knows what the heck I'm talking about with that. So I'll fill in those parentheses in a second, but again, I like to draw the parentheses first. What goes in here? Well, that would be 1 minus cosine squared theta. Distributing that would be 2 minus 2 cosine squared theta plus 5 cosine theta plus 1 equals 0. And after sort of going through the motions, combining everything, we would have negative 2 cosine squared theta plus 5 cosine theta, and that would be, plus 3 equals 0. Now at this point, I do not like the negative here, so we're going to divide both sides by negative 1. Now by doing so, we end up with 2 cosine squared theta minus 5 cosine theta minus 3 equals 0. And then at this point, we want to know if this is factorable. Well, actually, let's do u substitution. So we're going to replace cosine with u. So this becomes 2u squared minus 5u minus 3 equals 0. That makes things a lot less complicated. Just temporarily replace this cosine with a u, and therefore cosine squared would be u squared. And then the question is this factorable? Well, it would be factorable if this number times this number, which, by the way, is negative 6. If this number times this number, which is negative 6, if this negative 6 is such that it has factors that add up to negative 5, then this whole thing is indeed factorable. And it is the case that it's factorable because at the end of the day, negative 5 could really be composed of 1 minus 6. So we're going to split it up like that. And for the record, positive 1 times negative 6 gives me that negative 6. All right, so that's 2 factors of negative 6 that when added together give me negative 5. So we have 1 minus 6 right there. Then if you're going to do this sort of bomb method, which leads you to a place where you're going to do factoring by grouping, you would distribute that u, and you end up with 2u squared plus u minus 6 u minus 3 equals 0. Factoring by grouping would have us take care of one pair at a time. Let's investigate the first one. The greatest common factor is u. So it ends up becoming u outside, and it's 2u plus 1. And then it's always going to be matched over here, no matter what, if it's factorable, which it is. And the question is, what times 2u gives me a negative 6u? Well, that would be a negative 3, right? And you can also double check. Negative 3 times positive 1 gives you this negative 3. That's a really good sign. Now, whenever you're using the factoring by grouping stuff, you're going to want to then, you're going to want to then draw two parentheses, set equal to 0. One of the parentheses is going to have 2u plus 1, which is the MVP, and the other one's going to have u minus 3, which is basically everything that's left over here, other than the 2u plus 1. So that, of course, sets up two different equations where u minus 3 equals 0, 2u plus 1 equals 0. So we're going to review that right now. So setting up the first equation, and we'll bring it down here now. U minus 3 equals 0. Therefore, u equals 3. And we'll leave it alone for now. Looking at this one, 2u plus 1 equals 0. Therefore, if we were to solve it, we would end up with negative 1/2 equals u. Now, we know that u is not u, but u is actually cosine. So we're going to now replace it with cosine. Cosine theta equals 3. And over here, we'll get it over with. Cosine theta equals negative 1/2. So cosine theta equals 3. So in other words, what angle is such that the x-coordinate corresponding with this angle is 3? Are there any x-coordinates of 3 over here? Heck no. The largest x-coordinate we have is 1, right? We got negative 1 over here, you got 0 over here, and you got 1 over here. So this one is a waste of our time. That thing is out of here. However, this one looks promising. There's some angle such that the x-coordinate associated in here of this angle is negative 1/2. Well, clearly we see 2 pi over 3 fits the bill, and 4 pi over 3 fits the bill. So that would be, in a sense, kind of like, in a way, two answers, where one of the answers is 2 pi over 3 plus 2 pi k, and also 4 pi over 3 plus 2 pi k. That's how you do that one. So unfortunately, I'm out of time. That's all I can do for now, but I hope that this has been helpful. This is a nice review of how to solve these various trigonometric equations, and I hope for my student that it really helps for her test, which is coming up very soon. All right, so take care. If you have any questions, comment below.